Hello, Physics 1 students. It's Tuesday, October 30th, and Mr. Stevenson is your sub. I thought, since he doesn't have the ability to have a laptop, that I would do a demonstration of one of our free body diagrams. So from Schoology, you followed a link to a free body diagram activity, whether that was from the assignment or within the Chapter 4 Newton's Laws lab right here, free body diagram activity. When you hit that, it'll pull up the physics classroom. Inside the physics classroom, you can expand this. It gives us 12 situations, okay? I'm going to select one. I already tried to find some, but I'm going to select one that shows how to generate a free body diagram, okay? So we're going to look up here. Up here it says a rightward force is applied to a dresser to accelerate it to the right across the bedroom floor. Ignore air resistance. So this is my object right here. I've got a dresser drawer, which means I've got a downward force due to gravity. Most things will have a force due to gravity. I know it's sitting on the floor, so I need to have an upward force, right? And it gives me all these choices, right? And I'm looking for that normal force, that perpendicular to the surface of contact. Now I have options of gravity, normal, friction, applied, air resistance, spring force. We haven't talked about that. I hope there are no questions, but using it. Or tension. Okay, that's a pulling force. Now here's the thing. It's a rightward force applied, so I've got a rightward force applied. And that means there should be, right? It doesn't say ignore friction, so to the left, I'm anticipating friction. Now right now when I look at my diagram, I've got all the forces I want represented, but there's acceleration to the right. Didn't say acceleration upwards. I hope the dresser doesn't accelerate upwards. So normal force and gravitational force vertically need to be balanced, so they're the same length. If they're not the same length, there's going to be acceleration. So I'm going to go horizontally. It's going to be accelerating to the right, which means which side's going to win in a pulling contest, right? Applied. So applied force needs to be greater than the friction force so that it'll accelerate to the right. And that should cover it. Now there are scenarios where there are no forces, right? If I said none, right? I was on a leftward force and I got rid of it. I need to go back and get some friction force there. If I had them equal, they'd be balanced, therefore constant speed, right? And we'll change that. So sometimes there's going to be only force gravity. Sometimes there's going to be a tension force, so if there's some sort of cable. Sometimes they say ignore friction, right? Maybe it's on ice, okay? Sometimes the force is applied upward or leftward, okay? So hopefully you guys will be able to work through these 12 scenarios. They'll probably be different than your neighbors, so you'll need to work, but you can ask questions. Mr. Stevenson is so on top of it. He's seen it. We went through it a little bit, so he should be able to help you through it. I hope you have a great Tuesday. I will see you on your long day on Thursday, and I hope you have a great day. See you later. Bye.